In this video, I'm going to show you how to use the trigonometric ratios to identify the value of a side. In this case, we only have one side, so we can't use Pythagorean theorem, but we do have this angle, so that allows us to use the trigonometry to determine the value of this side. We have to recall our trigonometric ratios in order to determine which one we're going to use to solve for x. So recall that saw, ka, toa identifies our trigonometric ratios. So saw is the sine opposite hypotenuse, ka is cosine adjacent hypotenuse, and toa is tangent opposite adjacent. So we need to look at this angle here and decide what we have. So compared to this angle, the 19 is actually the opposite, and the x is the hypotenuse, because remember, the hypotenuse is always the side opposite the right angle. So we have, compared to this angle, we have the opposite and the hypotenuse, so we're going to use the sine function in this case. So sine of 58 degrees equals the opposite, which is 19, divided by the hypotenuse, which is x. So we have sine 58 degrees equals 19 divided by x, but we need to solve for x. So in order to do that, we're going to multiply first by the x on both sides. And when we do that, we end up with x sine of 58 degrees equals 19. But we're trying to solve for x, so we have to divide it by the sine of 58 degrees so that we can get x by itself. Now remember, we talked about the fact that the sine of 58 degrees is just a value. We can find that by putting it into our calculator. So let's do that. So when we simplify this information here, we get x equals 19 divided by the sine of 58 degrees. And we can calculate the sine of 58 degrees to be 0.848. Or we can just do this whole division all at one time. We could put in 19 divided by sine of 58 degrees. You can do it either way. Either do it all at one time, or first find out the value of sine of 58 degrees and then do 19 divided by 0.848. And that gives us 22.4. But what does that actually tell us? Well, remember, in our problem, we're looking for the value of x. So 22.4 is the size of our hypotenuse. And that makes sense because our longest leg is 19, and so our hypotenuse has to be larger than our largest leg. And so a 22.4 is a reasonable value at that point. Here in this example, we have the angle 68 degrees. We've been given one side and we're looking for another side. The side that we've been given in relationship to this angle is the opposite side, and what we're looking for is the hypotenuse because it's opposite of the right triangle. Therefore, since we have the opposite side and the hypotenuse, we're going to be using the sine function again. So I'm not going to work through that. I just wanted you to see that, but I'll show you the answer and the work. So try to work this one and then resume the video. Here's the answer. Okay, in this particular problem, we notice that we have our angle of 57 degrees. This time, however, we've been given this leg, which is actually the adjacent leg to our angle, as well as the hypotenuse. So we need to use the cosine ratio in order to figure out the x, because the relationship of cosine is using the adjacent divided by the hypotenuse. So that's what we're going to do with this problem. So here we have the cosine of 57 degrees equals the adjacent side, which is 18, divided by the hypotenuse, which is x, because cosine is the adjacent divided by the hypotenuse. That is where the ka comes from in sa ka toa. So we can solve this the same way. On both sides, we need to multiply by x so that we can get x into the numerator. And then once we do that, we just have to isolate the x. And in order to isolate the x, we're going to divide by the cosine of 57 degrees. So when we divide by the cosine of 57 degrees on both sides, we just get something that we can put into our calculator and get a value, because the cosine of 57 degrees has an actual value. So when we put that information into the calculator, 18 divided by the cosine of 57 degrees, it equals 33.0. And again, remember, we're trying to solve for this x, which is the length of the hypotenuse. Here's the last example that we're going to work on. It gives us an angle of 62 degrees, a side of 17, and a side of x. This time we don't have the hypotenuse. We actually have the side adjacent to this angle and the side opposite that angle. So in this case, we have to use the tangent, because remember, the tangent is the toa part of SOHCAHTOA, and tangent equals the opposite over adjacent. Now that we have the ratio set up, knowing that we are needing to use tan because we have the opposite and adjacent legs, we can solve for x. In this case, it's a little bit easier because x is already in the numerator, and so all we need to do to both sides to get x alone is to multiply by 17. So when we do that, we see that we get 17 tan of 62 degrees equals x. And so now x is all by itself, so we simply have to use our calculators and calculate 17 times the tan of 62 degrees. So the calculation shows us that 31.97 equals x, but we can round that to 32 equals x. And so now we've found the length of the long leg of this particular triangle. So that's how you work these problems using your trigonometric ratios.